Assalamualaikum to my panel, Dr. Rusmi alias. I am Nur Atilah binti Kamarudin, and today I'm going to present my research project 2, which is unsaturated content, deterioration, study of palm kernel oil-based alcohol. First, I will explain a little bit about alkyl polyglycosides. Alkyl polyglycosides are one of the industrial scale products of sugar-based surfactant, which consists of glucose or maltose as sugar head group linked with natural fatty alcohol as lipid tail. Synthesis of alkyl polyglycosides can be derived from palm kernel oil (PKO) because it is suitable for renewable sources in surfactant production because of an abundant availability. PKO-based maltosides is one type of alkyl polyglycosides. It is synthesized using Fischer glycosylations involving reactions between maltose as sugar head and PKO-based alcohol as alkyl chain. This research will focus only on raw PKO and PKO alcohol, which are starting material of productions of PKO-based maltosides, because limited time to conduct experiment using PKO maltoside sample. In this research, PKO was reduced to PKO alcohol using reduction method with the presence of catalyst lithium aluminum hydride. PKO consists of saturated and unsaturated component. Major fatty acid composition in PKO are lauric acid C12 and myristic acid C14, which are saturated component. PKO also contain unsaturated component, which is oleic acid C18-1. The objective of this research are to determine unsaturated content in PKO-based alcohol undergo reduction process to produce alcohol mixture using wet experiment and instrumental method. Next, to compare the reliability of the experimental methods. For problem statement, saturated fatty acid is more stable than unsaturated fatty acid. Unsaturated fatty acid is susceptible to chemical modification and very more likely to have double bond to degrading. The effect of catalyst to the double bond in this chemical modification need to investigate whether it influences the double bond to degrading or remain the same. Deterioration of unsaturated fatty acid means the chain molecules are shortened, which will affect the yield and quality of product. Next is scope of study. The scopes of study for this research are to analyze the unsaturated fatty acid compositions of the PKO when undergo reduction process by using two different methods, which are gas chromatography mass spectrometry or GCMS and iodine value. Since each of these experimental methods has different working principles and technique, the reliability of this method is being compared based on the analysis outcome of the composition unsaturated fatty acid in palm kernel oil. Next is methodology. The iodine value is direct proportional to the number of mono or polyunsaturated bond within constituents of fatty acid. In this experiment, the sample of PKO and PKO alcohol was weighted 0.05 gram and dissolved in 4 ml of solvent mixture of glacial acetic acid and cyclohexane, then added with 6.5 ml which solution. The solution was kept for 1 hour in the dark place for reaction to occur. After that, added 5 ml of potassium iodide and 25 ml of distilled water in the solution and stir well. Finally, sample was titrated with sodium thiosulfate with concentration of 0.1 molar as standardized solution. The titrated volume obtained will be used to calculate the iodine value. The experiment was repeated for 5 times with other sample to get an accurate and precise result. Move to the second method, which is GCMS. GCMS is used to identify the different substances in single sample and analyzes the complex organic mixture and biochemical mixture. In this experiment, the sample of PKO alcohol and mixed alcohol was diluted with ethanol as solvent with ratio of 1:10. Mixed alcohol, which consists of dodecanol, tetradecanol, cetyl alcohol, and allyl alcohol, was used as calibration purpose in this experiment. After that, the sample was measured using a 30 meter times 0.250 mm inside diameter times 0.25 micrometer column and programmed from 75 degrees Celsius to 300 degrees Celsius at 10 degrees Celsius per minute, and then final temperature was held for 5 minutes. The temperature of injector was set at 280 degrees Celsius and temperature detector was set at 360 degrees Celsius. Helium was used as a carrier gas in this condition. Next is result for this research. For the iodine value results from the table, it shows the iodine value of sample pKo obtained is accurate and precise, which are 20.3. The iodine value for sample pKo alcohol also shows the accurate and precise result, which is also 20.3. In this experiment, which method involved the addition solution of iodine monochloride, which contained in which solution, and mixture of acetic acid and cyclohexane. The solution became dark brown after mixed with both sample of pKo and pKo alcohol. After reaction happened, which is iodine addition to the double bond of the sample, the unreacted iodine monochloride reacted with potassium iodide and water and converting it to iodine. Then content of consumed iodine is measured by titration with sodium thiosulfate, where the color of the solution change can be observed. The solution changed from the dark brown solution to the colorless. For the observation, the iodine value of both samples pKo and pKo alcohol are compared. The iodine value of both samples does not change, which is 20.3. This shows the presence of catalyst lithium aluminium hydride in step of reduction process, where the pKo turned to alcohol mixture, which is pKo alcohol, are not influence the double bond to be degrading, because the reaction's effects on the carbon oxygen chain only and does not influence double bond between carbon chain. Hence, the double bond remains the same for both sample pKo and pKo alcohol. Next, move to the GCMS results. In GCMS analysis for mixed alcohol, the concentrations used were varied for each type of alcohol. The concentration of C12OH used is 0.1 molar, followed by C14OH with 0.05 molar, C16OH with 0.025 molar, and C18OH with 0.0125 molar. Based on the results obtained from the chromatogram of mixed alcohol, there are 4 peaks present indicating 4 types of alcohols. The height of the peak is depending on the concentration of alcohol. The higher the concentration of alcohol, the higher the peak of alcohol. The highest peak in this chromatogram belongs to fatty alcohol C12 due to the highest concentrations of among other alcohol. Based on the observation from chromatogram of pKo alcohol, all the peaks are representing on each type of the alcohol. In order to identify which peak does the alcohol belongs, the retention time of pKo alcohol sample where the peak existed need to be referred to the retention time on chromatogram of mixed alcohol, because it is used as calibration in this experiment. For the observation in this experiment, the fatty alcohol compositions in sample pKo alcohol will be compared to the fatty acid composition in original pKo. Major fatty acid composition in original pKo are C12 with compositions about 48.7%, followed by C14 with 16% and C18 with composition of 15%. Meanwhile, for pKo alcohol, major fatty alcohol compositions are C12, which is about 31.9%, followed by C14 with 9.4% and C18 with composition of 5.7%. From the observation, it shows the composition of each component are reducing from pKo to pKo alcohol. This might happen due to the chemical modification. The alcohol mixture, which is PKO alcohol, will produce from the reduction of PKO using a general reduction method. In this reaction, double bonds between carbon chain in the PKO alcohol are not affected. This reaction only involved with the carbon double bond oxygen chain being replaced with two single bond hydrogen. The efficiency of fatty alcohol obtained for fatty alcohol C12 is 66%, followed by C14, which is 59%, and C81, which is 38%. Based on this efficiency, it shows the reduction reaction from PKO to PKO alcohol influence the content of component compositions because the efficiency is below 100%. Then, next, referring to GCMS chromatogram of PKO alcohol shows there are extra peak which are existed before peak of fatty alcohol C12 at retention time of 16.65 minutes. Mixed alcohol only consists of 4 types of alcohol, which are C12OH, C14OH, C16OH, and C18-1OH. Hence, only 4 peaks in PKO alcohol chromatogram can be determined using mixed alcohol calibrations. The other 2 extra peaks are assumed to be C8 and C10. The assumptions are based on the retention time where the peak existed, because the shorter the retention time, the shorter the carbon chain. Since the extra peak existed before the retention time of fatty alcohol C12, then hence the carbon chain must be shorter than C12. For the final part, in conclusion, for this research, for iodine value IV method, the degree degradation of double bond in the sample was determined. The results show the IV of both samples of PKO and PKO alcohol are same, which is 20.3. It is acceptable since the values are within standard range of IV of PKO, which is from 14 to 21. The double bond does not degrade by the presence of catalyst in the reduction process, which is lithium aluminum hydride. Next, for instrumental method, GCMS was used to analyze the compositions of fatty acid component in the sample. Based on the results, it showed the compositions of major components are reducing from PKO to PKO alcohol due to the chemical modification. It can be concluded that the reaction from PKO to PKO alcohol influence the content of component compositions because the efficiency of fatty alcohol obtained is below 100%. That's all from me. Thank you.